Everybody, it's Tyler here at Chezy Champs, checking into number 973 Greybots, new division champions this year. And they actually have a new robot here for Chezy Champs that we'll be exploring a bit more into. By the way, I have Joseph and Jacob here to talk more about this awesome machine. Some cool features that we'll be diving into, why they made the changes, what they learned from this robot. Let's learn more about it coming up here on Behind the Bumpers.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Stryker's commitment to medical device technology innovation has made it a top career destination for those in First. First alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first.
So let's start out on your intake here. So you guys, like I said, made kind of a full set of changes. Talk about maybe the swerve and the intake, what's changed and what lessons you've learned from that as well.
Okay, so the intake is mostly the same as our competition season robot. We changed the geometry a little bit since our bumpers are lower because we switched to a swerve drive. We were also still having problems with the ball getting stuck between the pool noodles, so we added this wheelie bar here, so it gives the balls a little bit of a thing to react off of so they can go up into the intake nicely and not get stuck, and it works really well. It doesn't break. We've been really happy with this. But as I said before, we changed to swerve drive. This is like a new thing for 973. You know, usually we're known for like sticking with West Coast drive. We're trying swerve this year. So we want to try it. It can be better than West Coast drive. Like objectively, everyone is using it. It's getting easier and easier to implement, and it just kind of seems silly not to try it at least for an off season.
What did you guys go with for swerve?
These are like the MK4Is. We're also maybe going to try the other Maton models too at some point. But these ones we've been really happy with. They've been working really well. We've been having some trouble with the software issues and stuff like that, but we're getting those figured out.
What is something that you guys try and swerve on the spot here that some advice for other teams you give who are maybe looking at trying swerve for the first time?
So some advice that we would probably give to teams coming into this is allow yourself enough time to work out the bugs. Try stuff that you don't think will happen in a match because it will end up happening in a match. There's a lot of software bugs we've been facing where one of the swerve modules ends up acting kind of like a broken shopping cart wheel. It just tries to go a different direction than all the other modules, and that really tanks our driving throughout the match. That's one of the biggest issues we've been facing, getting all the swerve modules to work correctly together. And that comes down to a big issue with the Mark IVs just being capable of running with Neos and Falcons. The code with that, sometimes it doesn't work with the motors as well, and it confuses it a bit.
Let's start to continue on your robot here. We'll talk about like your tower stuff, but before we get to that, I want to talk about your material choice as well too. So you guys went with a wood type material for that. Let's talk to me more about utilizing that. When we were talking before the interview, you said that all this kind of came together in the last few weeks as well too. So just talk to me about the general superstructure of the robot.
Yeah, so a lot of teams nowadays don't really use wood as their belly pan or their side panels. We still do, especially during season.
Sure.
That was something we still did. We usually invest in a bit more expensive wood that's less likely to break if it were to take an impact. Last year, we got a new laser cutter in our shop, so that's been making prototyping faster, the creation of these side panels faster, and it allows us to do this cool hole pattern that makes wiring so much easier. If you look in the robot on the side panels, you see all the wires routed super neatly, and they're not in any danger of getting tangled in any of the moving parts of the robot and bricking our robot during a match.
So as we follow that cargo journey now into like your tower area, and then we'll bring in a cargo piece. Talk to me about your tower area and just kind of what you've changed, what you learned from the regular season.
Yeah, so during season we used the orange polycord belting to index our robot through to index the cargo through the robot. We saw a lot of issues with dead zones. We found that the ball would push the polycord out. It would stretch it when it got spun. The 3D printed pulleys that we were using to wrap around the polycord were failing after a while. So this year what we ended up going with was the timing belt from West Coast Products. We have 3 different belt runs. We have this tongue right here that spins like this floor belt that helps bring cargo in, and then we have this back here. We have this vertical run of belt that's kind of hidden by the front panel, and all of this allows us to index balls better. We're able to spin the tongue one direction and this vertical run a different direction, and that allows us to index balls and keep intaking balls until they're ready to shoot until they're ready to feed into the shooter. Another big issue we saw during the season was funneling of the balls into the actual conveyor. One of the ways we solved this that we saw other teams solve was these passive Omni wheels that sat on these vertical plates here. We've seen great success with these so far. We were ready to be able to power them if we needed to, but passively they've seemed to be working greatly.
Have you tried them being powered as well too, or you just went passive and they just worked out fine?
Yeah, if you look over here, there's these plates that are ready to accept a 775.
Yeah.
And we went in with the idea of trying to make everything passive, make it easier on programming, and it ended up working that they just worked passively. If they get stuck here, we'll bring the intake in, it'll keep spinning, and it'll just push it along these Omni wheels, and it'll go right into our indexer.
Can we see a piece of cargo come in, and then we'll wrap up and talk about your shooter?
Yeah. Enabling. Top left.
That's so smooth, man. Like,
yeah.
Wow.
Yeah.
All right, let's try to wrap up on this robot, talk about your shooter that you have on this. So love to hear once again what changes you guys have made, lessons learned from the competition season, and how it's been working out for you so far.
Yeah, so when it comes to the shooter, we used pretty much the same geometry, center to center distances on the shooter as during season. We found that shooter kind of just worked without a whole ton of tuning. So that was really nice for us. What we did do was we moved it an inch forward on where it made contact with the balls. We noticed that the ball was making contact with the front roller a lot sooner than the back rollers. We didn't like how that was interacting with the shot.
Sure.
It was giving us some unwanted backspin. So moving it forward that inch helped make our shot a bit more consistent. So that's the biggest change we've made to the robot shooter for this competition.
Yeah, well, 973, congratulations first off on a great season so far. It's always awesome to see your robots and what you come up with, and really cool to see different implementations for this robot here at Chezy Champs. So of course we wish you best of luck here, and can't wait to see what robots you come up with in future seasons. Thanks a lot, guys.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Stryker's commitment to medical device technology innovation has made it a top career destination for those in FIRST. FIRST alumni and mentors are given top priority in their internship and career applications. Come create the next medical innovation that saves lives at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.